like to talk about deployments, which is a very important part of DevOps. My personal favorite part, and also my favorite recommendation when people think about where should I start my DevOps life, if not started yet. And specifically, I'm going to show you a bit how do we do that with Kubernetes. That's how Google did it, and that's probably a good way for us to do it as well. So, 3 parts, a little bit about containerization first, because not everybody was an expert with Docker, so I'll just briefly go through why do we even do containerization, then introduction to Kubernetes, so that you understand a little bit about the basics, so that you can follow when I show you the demo. And then finally, a demonstration of how to do updates and how to run software with Kubernetes. It's very simple, so it's not the most, let's say, amazing demo, because it's so simple to do all the operations with it. So about containers. Traditionally, when we have a bunch of servers like we have here, and then we have a bunch of software that we would like to run on those servers, we have these problems, so that when we want to deploy our software, we have to decide on which server, and then we have to also install all the dependencies and the right versions, depending also on the version of the software. Or maybe we have different softwares running on the same servers, and then we have some conflicts of packages. And also then we have to migrate them. Well, if we have a cloud, we don't have to migrate, because we can always just nuke the virtual instances, and then we can launch new ones and have automated scripts like Puppet or Ansible or some other Chef, I don't know, others, Fabric, but some other tools to do it automatically, and then, okay, we're quite far. But I'm sure you agree with me that it would be the best thing to have the software, every piece of software, together with their dependencies, so that they could be in some neat package, and we could just deploy it as an entity, and we wouldn't have to care about all the configuration and other stuff on the servers, because it's included with software. And this is exactly what Docker does for us. So we can run containers of software with the dependencies and the environment packed into the software. And this enables us to do orchestration, allows us to deploy our software on whichever server, as long as we can direct our traffic into the right piece of software whenever we need that piece of software. So Kubernetes handles this for us. It balances the containers to our hardware, and also directs the traffic if we configure it properly. So about Kubernetes, a Google project initially in 2014, completely open source. That's lovely in comparison to some other products that cost a lot of money. In 2015, July, when it was released, the version 1.0, Kubernetes was actually given to Cloud Native Computing Foundation. So Google partnered up with Cisco, IBM, VMware, and Docker, and they have together taken over this project. A pod is a basic scheduling unit. Basically, it's just a container. Normally, a pod contains one container, and then we deploy it. So something that we want to schedule, a piece of software. So a pod can also have multiple pieces of software inside the pod, but it's not very common. Might be something like logging export or some other part that is related very tightly into the specific piece of software. Then we have replica sets. A replica set is a controller. It controls the state. If I tell the replica set to have 3 replicas of my pod running at all times, it will just periodically check that the replica amount is correct. And then if it's not, it will launch a new one or delete some extra ones. But the only object that I have to manipulate as a user is deployment. When I want to deploy my software, it is very intuitive that I create a deployment. So I create a deployment, and deployment internally creates a replica set to Kubernetes, and the replica set manages the pods, and all of that is defined in the deployment. So now if we take another approach, how do we access the software? There is the last very important basic piece is the service. Service is a metadata object, and it contains the information about the pods and where they are running in the cluster. So wherever my software is running, if I create a service, it's like an entry point, and it will load balance the incoming traffic into the pods wherever they're running. And then Kubernetes has also nice integrations. So if I'm running on some cloud provider, like now I'm running on OpenStack, I can automatically allocate a load balancer so that if I come from internet, and all these demos that I do, they are live, so you can access the same IPs that I can with your phones or with your computer or whatever. And the load balancer automatically comes and directs the internet traffic into the right service, and the service distributes it over the pods in Kubernetes. So the entire architecture is this simple. If I showed you this immediately in the beginning, it might not seem simple, but now that we know all the components, it's very simple. I have the only extra piece here is the Kubernetes control on the top. That's the thing when we see a black screen, my terminal, I'm using Kubernetes control. And then I connect to the master node, I tell, do a deployment, this kind of software and this main. In the examples, I first run some Nginx and then some other software. And I also tell with Kubernetes control to create the service, and the service will internally create a load balancer, and then we can access the software independent of which node it's running on. Some extra features that are really nice to know. Kubernetes also supports secrets, so if you ever had any problems with, let's say, your MySQL root password or whatever, when you have to give it to a Docker container, maybe the best practice, some might say, is give it in an environment variable, but I like more that I tell my cluster, okay, I have this kind of secret. It might be a self-certificate or whatever secret it is, I can give it to the cluster and it will store it for me, and whenever I launch a pod that requires the password or the SSL certificate, I can just say, just use this secret from the cluster, and the cluster will give the secret into the pod. Another nice integration, if we have available in the cloud provider some persistent storage, we can use it in the containers. If we have a database container, so if I have OpenStack Cinder, I can make a persistent volume, a block storage, and I can mount it into the database and then use it there. Okay, so maybe the last question, is Kubernetes ready yet? Well, I think that Kubernetes is ready. The most of the not so ready things, this is very new. It's September 22. I made one improvement to Kubernetes, but it's only related to integrations into the cloud providers. So the core is it's very mature and good. So I think yes, it is ready, and after Christmas it's also ready for the OpenStack users when this comes out. Limitations, other than that, Kubernetes does not do sorcery. Okay, that's a joke, because everybody knows that Kubernetes doesn't do sorcery, but sometimes people expect platforms to do some very weird things, like if you can't scale or migrate or replicate your database, then Kubernetes can't do it for you either, because it's not magical like that. But if you can do it, then it can do it as well. In the demo, I will show you first a rolling update. So I'll deploy some Nginx servers. I have two instances of Nginx. One of them is with green background and one of them is with blue background. They are in Docker containers, and then I can show you a green-blue update. So what actually happens is that when I tell the deployment to deploy another Docker image, it will create another replica set internally and then scale down the original while scaling up the new one, and on the fly we can have a new version. And the service will just direct on any pod that is running, so the service doesn't really care about this. Another way of doing the same is that we can run entire stacks of our software, no matter how complex they are. We can run them in the background and then just switch the service. This I call green blue update. Some might call it A/B testing or whatever, but it's the same thing anyway. So we can run the entire software and then we can switch where we direct our traffic. And then finally, I can show you that it's also easy to deploy some more complex application. This is a 5-part microservice application by Docker. I have tuned it a little bit to be more suitable for DevOps events. And then it's running on Kubernetes, and all these pieces can communicate internally within the Kubernetes DNS, so that we can vote on the voting app, and then I can present the results on the results app. So thanks for your patience, and now I'll show you how we do this in practice. So I have a Kubernetes cluster that I installed yesterday. If I show, there is some system services running, plenty of them, but we are not. That's very annoying. Sorry. Okay. So we're not very interested in the system services, but if I check my pods, I will not have any pods, and I only need one thing to make it faster, and that thing is my notes. I don't want to do anything wrong because we don't have that much time to waste, and I do not want to waste your time. So when we deploy anything, it's very similar to Docker. When you say Docker run, you can also say kubecontrol run, and then you tell what? A deployment. So let's run an nginx deployment with an image, my image from Docker Hub, and it's nginx, and the version is green, and let's say it runs on port 80. Okay, I can verify by getting the pods. It's already running, that's amazing. And then I can create a service for us to access this by using kubecontrol expose. So I can expose a deployment with kubecontrol expose, and then I tell that I'm exposing a deployment that's called nginx deployment, and I want to give the created service a name, and that's going to be nginx service. You could have guessed that probably. And then the target port where it's running is 80, and I want to also tell Kubernetes to allocate a load balancer. So we do a load balancer type service, so it allocates from the cloud provider a load balancer. If you see me typing a typo, please tell me. You can also count how many mistakes I do during this demo. I'm trying to minimize them to 0. That's the best practice. So we can verify. Get service, and if I also use a wider print option, then we can see that it has some cluster IP, but it doesn't have external IP yet. And why is this? It's because it already told the cloud provider to bring me a new load balancer, but it takes a few seconds for the load balancer to be up. And actually now if you go here, with your phones, you can also go into the same address where I'm going. It's 193.65, 106, and then 199. You can also you can observe this demo while I'm doing it. So here's the Nginx. I left my servers in Finland, but they're still serving me here. And then, if we want to scale the Nginx, we can use kubectl scale. I'm scaling the deployment called Nginx deployment, and I will just define the amount of replicas that we need, and let's say I create 4. My Kubernetes is divided between 2 availability zones, so that means now I have two instances of Nginx running on both availability zones. We can actually verify this by doing get pods once more with option wide. And we are running, and this is the number of availability zone, and this is the number of the index of the node that is running within the availability zone, if you're interested. I don't know. Now, when we want to do a rolling update, that's like the easiest update we can do, right? Maybe not in the traditional hardware setup, but with Kubernetes it's really easy. So I can just edit the deployment. Okay, and the edit command will launch my favorite editor, VI. It's not your favorite editor? I hear something. Yeah, that doesn't mean it couldn't be my favorite. So I'm changing, for all the containers run by this deployment, I'm changing the image. I want it to be Nginx Blue instead. And write and quit. And then we can see what happens here when I describe the deployment. There are some events. The events are that it's reducing the amount of running pods in the older version and then increasing them, scaling them up on the new version replica set. And when we go back to Nginx, it should be blue. Okay? If it wasn't blue, it would be because of my browser caching, not because of Kubernetes. But anyway, it is blue, so everything is just as expected. Do we like blue color more than green, actually?
Yeah, way better.
We do.
Blue is best.
But the thing is, I don't. Let's say I really hate blue color. So I'm actually, to hurt your eyes a bit more, I'm going to do Kubernetes roll out undo for the deployment Nginx deployment. And then if I would check the events again, we have some more events. And then it should be ugly green again. This is actually ugly green. I tried a bit, but it's not on my interests to put a lot of effort in finding the right color, as I'm not very artistic. So, I mean, I can only produce you an ugly green or an uglier green. So this is the best I can do, sorry. So now it's green again. So now if you want to try the green-blue update to make it your favorite color blue again, we can instead run another set, another deployment, and then we can direct the traffic into the blue one. So we do kubectl control run again, and we run a deployment called nginx blue this time, and then I will put directly 4 replicas up. What did I do? There is no image. It's not nice to run anything without an image. Yeah, that's right. So now we can verify. We have some blue nginxes running as well. That's right, we do. So we can edit the service to direct the traffic. Instead of the green one, we can direct this service into the blue one, like you saw in the picture here. Okay, and last time we edited the deployment, now we edit the service. Okay, and there is only one interesting thing here. The selector. Selector defines where the service will direct the traffic, and the nginx deployment has some labels in the pods that are called nginx deployment, and then the nginx blue deployment has some labels that are called nginx blue. So let's just forward the traffic there, and it should be effective immediately. Okay, it's blue again. And even if this was a more massive set of software running and there are some dependencies, we can deploy all of that first and then just direct the front end into the new version, or a different version, or entirely a different software. I don't know, you try to go to an old application, you end up in something completely new. As a surprise for April the 1st. And that's all. If I were to conclude, I would say that Kubernetes makes the actual operation of doing a deployment or deploying any version that you have very simple. As you can see, even a half moron like me can do it easily. So that's it. Thank you. I'll take any questions, and I'm also here all day, so you can talk to me at any point if you have any questions. Thanks.